Good afternoon, guys. We've got our mobile elevated work platform webinar. It's fixing to start. We're a minute or two early. We'll give some people a little more time to hop on, but figure we'll start, I don't know, 1 or 2 minutes after the hour. So you need to go refill your coffee, which shouldn't be drinking after lunch, right? Or get you another drink. We'll get started here in a little bit.
Good afternoon, everyone. Thanks for joining us on the TXOA webinar on MEWPs. We're likely to get started around 1:03, so if you guys need coffee or water, go ahead and do that. If you've already been on, sorry if this is a repeat message for you. I know JB just said this, but for those of you that just jumped on, we'll start here in a couple minutes.
Good afternoon, everyone. Guess we'll get this show on the road. It's 3 after the hour. For those that don't know me, I'm Jeremy Baldwin with Diamond Communications and also the VP of TXOA Wireless. We'll have a webinar today talking about mobile elevated work platforms, which Shane will do an introduction on that. I just wanted to do a little quick house cleaning. We've got our inaugural fall golf event for TXOA since we merged Texas, Arkansas, and Oklahoma together. It's on October the 22nd and 23rd in Tulsa, and we've sold out all of our sponsorships, whole sponsors, all that. We've got right now it looks like 4 golf teams left and 18 slots for poker. So if you want to be there for the inaugural event, you better get on it now because I don't think we got 2 months left, a little less than that. I figure we're going to sell out. With that, I'll throw it over to Shane so that he can make the introduction to the Josh who'll be putting on the webinar today.
Thanks, Jeremy. Uh, This webinar on MEWPs is meant to be a high-level overview of the safe operation and training for mobile elevating work platforms. It's not intended to replace any sort of training program or certification program that you already have in place. It's an informational session only. For those of you that don't know me, my name is Shane Campbell. I'm the Executive Vice President of Safety LMS ComTrain, as well as the Safety Committee Chairperson for the Safety Committee on the TXOA. Just a few administrative details before we begin. On the top right of your screen, you'll be able to see a little area that's a comment section or question section. If you guys want to submit a question, feel free to submit it there. Likely, we're going to wait until the end for Josh to answer any questions. That way it doesn't disrupt the presentation, as well as your question may be answered throughout the presentation. And as always, we'll be posting this webinar to the resources tab of the TXOA website. So if anyone missed this presentation, or if you'd like to watch this presentation back, feel free to join the TXOA website and click on the webinars there. It'll be posted within a few days. With that, it's my honor to introduce Josh Dermott, who's the lead safety manager with Neticom LLC, and who'll be giving this presentation.
All right, sounds good. Thanks, Shane. Thanks, guys. Thanks first and foremost for everybody who's able to be here today. As Shane said, this is a high-level overview. It's kind of meant to give you a glimpse of what it looks like to be safely operating and using mobile elevated work platforms, as I'm going to say several times throughout this presentation, MEWPs. So let's get started. Going into objectives first. So kind of what we're going to talk about in this presentation. We're going to touch briefly on standards and regulations, so you kind of know where we're getting this information from and what the requirements are. Your different groups as well as types of MEWPs and how those two things function together. Roles and responsibilities. This is the actual people involved in the renting, operating, writing on of MEWPs. Training requirements, hazard assessment, which is a huge one, fall protection, rescue planning, load handling, and traffic control and dropped object prevention. As Shane mentioned, again, I'll just reemphasize this. This presentation is meant to be a high-level overview of working with MEWPs. The presentation shall not be considered a training course for certification. And then this presentation does not represent TXOA or their views. And TXOA takes no legal responsibility for the correctness, completeness of the materials presented. You always go get more information from your standards and regulations. So now with that out of the way, let's get this thing going. Starting with standards and regulations, because this is kind of the baseline for getting the MEWPs out there, right? Using those MEWPs. So we follow a good amount of standards and OSHA regulations that are available for you. First and foremost, your ANSI regulations. So there's three main ones that we have to follow when it comes to operating and using mobile elevated work platforms. First and foremost is the ANSI SAIA A92.20 2021. Basically, this ensures the manufacturers build MEWPs, standardized safety features, structural integrity, stability, and performance criteria. This sets the baseline for making sure that man lifts are actually being manufactured in a reputable and safe fashion. So that standard more points towards the manufacturers of these man lifts, but it's still important that, especially if you're in a position of safety or management, that you're familiar with all of these standards, so you know where they're getting their requirements from, as well as your requirements. When it comes to the safe use of mobile elevated work platforms, you find that in A92.22. This standard defines how MEWPs should be used safely, including the responsibilities, which we'll talk about in a little bit, maintenance, and then some operational control aspects. Then you have A92.24, which is training requirements for the use, operation, inspection, testing, and maintenance of mobile elevated work platforms. And this standard just basically sets the baseline for how you are supposed to train your workers and anybody else involved in the operation, supervision, and maintenance of running a MEWP. In addition to that, you have your OSHA standards. Subpart L covers aerial lifts and scaffolds, and then subpart M gets into the fall protection aspect of using man lifts. So again, all of these standards and best practices are a really good baseline if you are developing a MEWP safety program for your company, you should really be familiar with these. Moving on, so let's kind of set the baseline for the different types and groups of MEWPs, because they're not all the same, right? So when you get into groups, the very first one is Group A. This is your standard scissor lift platform that moves vertically but stays within the tipping lines at all times. So we can move it around, but we're only going up and down. We're never getting outside of that tipping point. That gives you a Group A man lift. Group B is anything else that can move outside of the tipping point. So typically this is with a boom. There's other formats, but this is what we're used to seeing in the field, right? Most operations, as far as working on telecom sites, you're looking at something that falls into the Group B, just because it's more applicable to the work that we're doing. Scissor lifts can be useful in some applications, but not so much as what we're used to seeing in the field. So once you've established what your group is, either A or B, you got to go figure out what type you're working with. There's technically three types of man lifts: type 1, type 2, and type 3. Type 1 being that the traveling is only allowed in the stowed position. So when you are actually moving the man lift, you have to lower it all the way down to the ground, and then you can move it.
Hey,
Type
Josh.
3,
Hey, Josh,
yes.
can your screen, I think maybe trip something up, show these lifts like A, B, and C, like I can't see what you're looking at. If you can, we're still like on the first page. I don't know if you can.
The very first page.
Yeah, it's
Yes,
not
sir.
in presentation mode anymore.
There
Guys,
you
I
go.
apologize about that. I'm just talking.
Oh, you're
We
right.
may just have to go like this and make sure everything, it is what it is. We're just going to roll like this and make sure you guys can see everything. How about that? So it sounded like you didn't get to see anything that I was showing, yeah? Um, So let's back up just a little bit. So you have Group A and Group B. Going back to scissor lifts, just like you see here. Group A, straight up and down, stays within the tipping lines at all times. Group B can move outside of that. This is where your standard, or more standard to what we're used to seeing in the field, like a regular boom lift. As far as your types, you get type 1, type 2, and type 3. The most prominent ones that you're going to see are type 1, which requires you to fully lower the platform into the stowed position before you can move it. And then type 3, which can travel while elevated within reason, depending on the manufacturer. But the basket's going to be a little bit off the ground when you're moving around. Um, Typically, you can move those by using the controls in the work platform, but a lot of times they may be combined with Type 2, which allows you to move the man lift from the controls on the chassis. Type 2 lifts are pretty uncommon because normally if you have controls on the chassis and you can move it while elevated, it's also going to include those second set of controls in the basket. So for the purpose of this presentation, we're really only going to focus on types 1 and type 3, as well as groups A and B. So what does that mean? Type 1, group A. So we're getting into groups and types combined. So we kind of get a look at what the different types are when you combine them with groups. Type 1, group A, travels only in the stowed position, and the platform stays within the tipping point. Scissor lift, right? Then you have type 1 group B. They can only travel while in the stowed position, but the platform can move outside of the tipping point. You'll typically see these in like a tow behind sort that you may rent for small type jobs. Type 2 group A. Travel while elevated, but the platform still stays within the tipping point, so you don't have to move it all. You don't have to completely compress the scissor lift in order to move it. And then you have type 2 group B, which is what we're used to seeing in the field typically, where you can travel while elevated and the platform can move outside of the tipping point. So now that we've established what the groups and types of the man lifts are, we need to kind of go into what are the roles of the people involved. There's quite a bit here, so I'll try to go through it as in detailed as I can. Starting at the top, you have your manufacturer. Your manufacturer is just that, right? It's their responsibility to design MEWPs to ANSI standards. They supply manuals, training information, and safety bulletins. Okay. In addition, they must also be able to provide operational and maintenance instructions and to identify the hazards associated with operating or repairing their specific MEWP, right? Then you have a dealer, right? Dealer is responsible for taking that man lift and maintaining it in a safe condition provides required. They also provide the required manuals, records, and service. When requested by the user, the dealer must offer the operator training or advise the user where training can be obtained. So now we're going to start getting into those are the guys outside of your company. So now we're getting into the guys that are inside your company, starting with your employer, right? So it's your employer's job to select the appropriate MEWP for the task. They also are responsible for ensuring that the operator and occupants are trained, right? Can't use anything without training. In addition, they are responsible for completing site-specific risk assessments, rescue plans, and enforcing safe use. So your management team. Your supervisor, you may or may not have a supervisor in this role. It kind of depends on the layout of your company. But the supervisor's role is to kind of ensure that the MEWP operations follow site safety plans and verifies operator qualifications. In addition, they oversee hazard controls and compliance during the work. So that's kind of like the management level. Now you're getting into the guys actually into the basket, which is our double O's, your operators and occupants. Your operator, of course, must be trained. In addition to being trained, they must be familiarized with that specific MEWP model. If they're not familiar with a specific model or a model from a manufacturer, they have to be refamiliarized each time they're presented with a new man lift. That way they can operate it safely in all scopes. In addition, they should be able to perform basic pre-use inspections per the manufacturer's instructions. And then finally, they need to follow all site rules, manufacturer instructions, and they're responsible to operate the equipment safely. Finally, the occupant. This is somebody who's in the basket, but not necessarily touching the controls unless it's an emergency. They must receive a safety briefing from the operator, know how to use fall protection, and understand emergency descent and rescue procedures, just in case something happens to the actual operator. Okay, so we mentioned that it is a requirement that anybody involved in the use of the man lift needs to be trained. So some of the basic training requirements. This is still kind of following the roles and responsibilities format. So the employer, they have the responsibility to train and familiarize or verify training for supervisors, operators, occupants, and then you must maintain those training records because if you didn't write it down, it didn't happen. Your supervisor must be trained in the proper selection of MEWPs, standards, regulations, and potential hazards. That way we're picking the right equipment for their job. Your operator needs to be trained per the ANSI SAIA A9224 standard. There is a classroom portion to that, and there needs to be a hands-on familiarization portion. The standard, if you dive into that, actually outlines the exact methods and everything that you're supposed to train those guys to. This is not a full-on training course, so we're not going to dive into that too deeply. But just know there needs to be a classroom theory portion that meets the ANSI standards and a hands-on familiarization with each man lift they may operate. If you're looking for trainings like that, if you have a brand that you like to work with, specifically reach out to that manufacturer. Most of them offer this type of training and you can get it for pretty cheap, but it's absolutely critical that your operators and your occupants are trained. Moving on to the occupant, they must be trained in emergency operation controls should something happen to the operator. They need to know their fall protection requirements, potential hazards, actions that could affect the stability, such as moving too much equipment to one side and offloading the boom mount. Safe use of accessories, site-specific work procedures, and manufacturer's warning instructions. That way they can be a safe passenger. Then we covered training. There are some times where you may need retraining. Okay, the obvious one here is if the operator's certification has expired, right? Depends on the trainer and the manufacturer, but typically 2 years is what you're looking at there. If there's deterioration of the operator's performance, if during a safety audit or observation, the operator is observed not following the manufacturer's recommendations, operating in an unsafe manner, that person needs to be brought in and retrained to get those skills up to speed. The operator experiences extended period of with no operation of the MEWP. Say you go train a new operator, and then he works with you for a month on a job that has lots of man lift operations. And then he just goes off and climbs towers for the next year and a half and never touches a man lift. Well, another job comes up uh, down the road and you need him to run a man lift again. A year and a half is a long time to not touch the controls for something that you need to operate that's heavy machinery. That person needs to be retrained and refamiliarized with the equipment before you put them back on it. The operator's introduction to new or significantly different MEWP technology, man lifts come in a very, very wide variety, right? Not one of them is built the same. So which each one that you put into the field, you need to make sure that they're trained and familiarized to that. The operator is involved in an accident or near miss with the MEWP. So anytime that we have an accident or near miss, we want to bring it in, do a root cause analysis, figure out what happened, and shore up that training to make sure that we don't have an incident, especially in a near miss case. Moving on to hazard assessment. So this is a biggie, right? When we're talking about hazard assessment, there's kind of a flow that you want to follow. Very first and foremost, you need to identify the task. Okay, what are we trying to accomplish with this man lift? What do we need to get where? Is it people? Is it people and materials? How long are we going to be working on a specific job? How high are we working? What are we dealing with there? And once we've got a nice scope of work outlined, we want to go then and select the appropriate machine based on a bunch of different factors. Scope of work, work site constraints, what's the rad center or the height, ground conditions, site access. You may not be able to get a big enough lift in there. And then proximity to public or other workers. So once we've selected our man lift that's appropriate for our job, we have to assess the hazards. Okay? We have to take a good look around and say, what are we dealing with? What kind of potholes, electrical, whatever it is that we're dealing with? We need to get those and document them. And for every hazard that we identify, we have to identify a control. So now that we've established what our hazards are, the final step is to get our controls in place. Follow your hierarchy of controls to engineer and remove and whatever you need to do to get those hazards out of the way so you can safely perform your work. I did put a note in here because it's important to say that when you do a man lift specific hazard assessment, it does not necessarily replace the need for a general job hazard or job safety analysis, whatever you want to call it. They're kind of separate from each other. One is more specific to the whole overview of the job, and one specific to the operation of a man lift during that broader scope of work. So moving on to some common hazards. Um, when it comes to common hazards, as far as they relate to man lifts, um, falls is obviously a big one, right? Anytime we're working at height, this is what your brain immediately goes to. Failure to use fall protection, ejection from the platform for misuse, unstable conditions, wind loading, things like that. All of these things can cause a fall, and that's what we're trying to avoid. We want to keep our guys in the basket. Then you have tip overs, right? Tip overs are typically brought on from operating on unstable ground, rolling over potholes that you didn't even see, and the wheel pops into there and topples you over. High wind conditions or improper use of things like stabilizers and outriggers. You can go on and on and on. There's a million things that can cause one of these machines to tip over that you need to be aware of. Electrocution has been a big topic in our industry as of late. Um, Making contact with power lines with one of these machines is definitely not something you want to do. We'll talk about minimum approach distances here in just a little bit, but that's something you definitely need to be looking around during your hazard assessments and look up. Okay, not just what are we dealing with on the ground, but what could we make contact with that could be a major issue for our guys in the field. Um, excuse me. Caught in between and crushing hazards, environmental such as wind and ground conditions. There could be equipment failure, right? I think we've all had the experience where we get a man lift delivered and that thing comes in just looking all beat up. And if you accept that man lift versus turning it away and saying, hey, no, I want another one, you could be looking at major equipment failure. And that could cause all sorts of the other things that we've already listed above as far as hazards are concerned. Visibility and lighting, if you have to operate at night, dropped object hazards, anytime you take something up, right? There's gravity is always trying to pull it back down to the ground. So we need to have a plan for keeping dropped objects out of the way. Unauthorized or improper use, and then overloading. I mentioned earlier that for every hazard that we find or discover during our hazard assessment, you need to have at least one mitigation. It's a 1 to probably more than 1 ratio, but if you identify a hazard, you need to have a mitigation. So when we look at these sorts of things, when it comes to falls, what are some of the mitigation techniques that we use? This list could be the entire presentation if you wanted to sit down and go through actual hazards and mitigations. But just to name a few, when it comes to falls, pre-planning is huge, right? Having a good, effective plan for what you're going to do with that lift. Using things like drones, if you need to go up and capture some photos and you don't want to expose or re-expose your climbers to a fall. Using spotters and traffic control, and then of course, fall protection systems are critical when we're working at height. Tip over, worksite inspections, overload prevention, and wind monitoring. I mentioned earlier when it comes to electrocution, you want to be maintaining your minimum approach distances. These do vary from manufacturer as well as the voltage that you may be dealing with. But the little screenshot I have here kind of gives you a good look at what are we dealing with, right? In my opinion, I am no electrician. I've never been a lineman. I don't really have a desire to be. I'm going to be trying to maintain that 45 foot at all times. Unless, and if I have to get within that with a man lift, I'm not trying to identify lines. I don't have that capability. I'm either going to be looking to de-energize or I'm looking to maintain at least that 45 feet from lines. If I have to get within that minimum approach distance, I'm getting somebody a lot smarter than me involved to make sure that we can do that safely. And with that, you want to have dedicated spotters, right? When you're running that man lift, your brain is going a million different directions, trying to make sure you're operating the control safely, watching all around you. Having a good set of spotters to make sure that you don't hit something you didn't want to hit, especially high voltage lines, is a fantastic idea. When it comes to caught in between and crushing, again, dedicated spotters. I can't recommend that enough. Put a guy on the ground to be your watchman. High visibility clothing for the guys that are on the ground. Make sure you're controlling your traffic and pedestrian. And then warning lights and sirens on the actual machine to warn others who may or may not be paying attention. Um, when it comes to environmental, wind monitoring and is a huge one. If you don't keep some sort of wind meter in your toolkits, I highly recommend you get them. They're super inexpensive, and you can get a real glimpse at what you're dealing with, not just guessing, saying, yeah, it's a little windy today. Many manufacturers will limit the operation of their man lifts to between 15 and 20 miles an hour, depending on the manufacturer. It's not very windy, but that's because especially if you're getting these things at 185 feet in the air, that wind becomes a major factor. And then, of course, you want to be using proper matting in unstable ground conditions. When it comes to mitigating equipment failure, pre-use inspections, this is probably one of the most commonly missed things we see in the field is guys just go from day, they may do it on the first day, right? When they get it delivered, everything was good. Day 2, 3, 4, 5, 6, they just assume it was just as great as it was the day before. And all of a sudden they've got lines rupturing and they're stuck 150 feet in the air and their emergency controls are not operating as intended. Make sure that when you are doing rentals, that you are dealing with reputable dealers and manufacturers. That way, the odds of you getting a bum machine are much lower. When it comes to visibility and lighting, anything you can do to create light. And ideally, we're not operating the machines at night. I understand there are situations where you might have to, but daytime work restrictions are a really good practice. And that goes for a lot of things in our industry, not just man lifts. And then when it comes to dropped objects, you want to be looking at tool lanyards, closed top canvas bags, and then make sure you're planning and securing all of your loads. Some mitigation techniques for unauthorized and improper use, maybe training or monitoring by a qualified person to ensure that your operators are performing correctly. And then overloading, again, training. Bring awareness to what you can and cannot do with these machines. And if you need to perform a task that the machine cannot handle, bringing in something like a crane and working in tandem with something that can handle the heavier loads is highly recommended. I know that was a lot, but there's a lot to go through there. Um, I mentioned earlier with pre-operating procedures, there's of course you have a certain amount of inspections that need to happen. But it's not just the operator who has inspection requirements. The annual inspection needs to be done by the owner or dealer of the man lift, and they should be able to provide that inspection proof to you within the last 13 months. Ideally, it's once a year. And if you're getting delivered a man lift that does not have that yearly inspection, refuse it. Turn it away and say, hey, I either need you to give me proof of inspection or get me another machine. Um, it's the operator's job to verify that, but that ideally would be done before the machine gets to site to save time. The pre-start inspection, so prior to each day or shift, the intended operator must perform a pre-start function test. There are outlines in the A92 standard that say exactly what that operator is responsible for when it comes to inspecting a man lift. We won't go too much into that here today, but I did highlight the standard there if you want to take a screenshot or that, whatever. It's a pretty short list of things, all things considered, but everything on that list is absolutely critical. I highly recommend either getting a form from your manufacturer or creating a form yourself, some sort of checklist to give the guys a little reminder of, hey, this is what you need to be looking at, checking for, and not just each day, but each shift. So if you leave and come back for some night work after a early morning daytime shift, you got to reinspect all over again. Outside of inspecting the actual machine, the workplace needs to be inspected. This goes back to the actual hazard assessment, but you need to be looking around for holes, drop-offs, ground conditions, any slumps, bumps, especially overhead obstructions and electrical hazards, and then verifying that your weather conditions are actually good to go. Once you've done all these things, you're good to start your machine and get up in the air. Once you've actually made it up in the air, we need some fall protection. Okay, the primary fall protection system for all MEWPs is the guardrail, right? Whether you're talking about scissor lifts or man lifts, that's the main force keeping your guys inside the basket, but only when they're used correctly, right? So once you're inside the basket, all gates must be closed and latched. And at no point should you sit, climb, or stand on the guardrail at any time. These handrails are also not meant to be used as anchor points unless specifically outlined as such by the manufacturer. We'll talk about this here in just a bit too, but all manufacturers are required as part of that ANSI standard for manufacturers to provide sufficient anchorage points, label them as such, so you know exactly where you're supposed to tie off. When we're talking about Group A, so we're going back to Group A and B. So if we remember, Group A is things like scissor lifts. They stay within that tipping point, straight up, straight down, never veering outside of that. Your secondary fall protection or restraint system is recommended, but not necessarily required unless by the manufacturer, risk assessment, or policy. I highly, highly, highly recommend that you have a company policy that says no matter the type of lift, we're going to put you in a fall protection or restraint system. It's just silly not to. It's not a big inconvenience to wear these, but it could be a pretty big inconvenience to get tossed out of one of those scissor lifts. Group B MEWPs, so anything that can move outside the tipping point, you absolutely have to have additional fall protection. That guardrail is not enough because there is a massive risk of being removed from the basket forcefully, either in a tip over or a catapult-like event. So it is required that you have a full body harness, no body belts or anything like that. We've moved on from that as an industry. Um, a fall restraint lanyard is the best thing that you can put on, in my opinion. Something to make sure that's short enough to keep you inside the basket should you have a violent bump, right? We want to always get pulled back into the basket. If you don't have something like that, you could use a maximum 6-foot length self-retracting device. Also a great option to make sure that your guys are staying inside the basket in the event of a catapult is the term I like to use, because we can get that seatbelt-like effect to make sure they stay in the basket. A combination of restraint and arrest. It is not acceptable to place two double locking snap hooks because they can work against each other to a single D ring. So if you do need to have a combination of fall restraint, fall arrest, maybe you have a single leg lanyard to keep you in the man lift, but you're going to have to transition out of the basket later. It's recommended that you use a D ring extender to separate the two devices. However, you should, in addition, I'm sorry, I should say, you should never use the side D-rings on your harness for fall arrest. Okay, so make sure that you're not only providing your guys with ample fall protection, you're training them in how it's used, and you're giving them the right equipment. Just handing them a 6-foot free fall lanyard and saying, "Have at it, buddy," is definitely not the way to go. There's better ways to do this. 6-foot free fall lanyards, on that note, they may be used when the platform is above the calculated fall distance. So that's great as long as you're about 15, 16 feet off the ground. But a lot of these times we're going to be moving the man lift from place to place, and our guys are only going to be about 7, 8 feet off the ground. And if they were to hit a bump and get catapulted out of there, that Y lanyard isn't going to catch them before they strike the lower level. So using something like a fall restraint lanyard or an SRD in combination with those other fall arrest lanyards you may need at height on a tower structure is highly, highly recommended. On that note, when we're talking about fall clearance, you need to be considering your fall clearance not just for the obvious, which is when you're moving the man lift from place to place, you could be tossed from the basket and strike the ground. That's again, like I just said previously, that's why you have to have the fall protection, even while moving the man lift from place to place. And it should be an SRD or fall restraint, so you cannot strike the ground when you're moving at a lower level. But what about when you're up in the air? Okay, if you get tossed from that basket using a 6-foot Y lanyard, you're still going to take into consideration the clearance as if you were just working on the tower. Many of us know that when you're working on the tower, we have to consider, okay, is there other sectors below us? Is there microwaves mounted at the tower? What are we looking at that we could possibly hit that's not necessarily the ground, but what's at height that becomes a lower level or obstruction? Um, and the same is for when you're working out of man lifts. If I'm approaching the tower and I get tossed from the basket, and there's a possibility that my free fall lanyard or 6-foot free fall lanyard may allow me to strike something below the man lift platform, you really need to take that into consideration with what kind of fall protection equipment you're giving the guys or that you're using yourself. So anchorage, as mentioned before, anchor points must be provided and equipped by the manufacturer and labeled as such. Again, I cannot emphasize this enough. 99% of the handrails or guardrails you see out there are not designed to be tied off to. You need to be anchoring to the designated anchor points that are installed by the manufacturer and labeled as such. These anchor points must be clearly labeled and rated for fall restraint and arrest. All occupants must comply with manufacturer's instructions for anchor use. And this is a big one. Each anchor must be inspected by a competent person prior to use. Never, ever, ever trust somebody else's work, right? Even if it just got delivered that day, do a competent person inspection of that anchor point to make sure that it's in good condition and that it's not going to fail under pressure. So what do we do? Like everything's going great, and then all of a sudden it goes bad. Okay, we have to think about rescue. Rescue is something that I've seen in the field as often neglected. They go, "We're in a man lift today, and we're not going to get out of the man lift, so we're just going up, we're going down, easy peasy, no climbing, awesome." It's not the case. Rescuing from a man lift can be a very, very tricky situation if you don't have the proper equipment and training to do so. So with that comes the requirement, just as if you're working on a tower structure without a man lift, you have to have your written rescue plan. This rescue plan is typically separate from your written rescue plan for just doing normal tower work, and is more geared towards what are you going to do if you get tossed or somebody gets tossed from the basket of the man lift and you need to rescue them from there, or if there's a failure in a system failure that would cause you to potentially have to be rescued out of the basket, even if you're just standing in it. So with that rescue plan, all occupants must receive training on the emergency procedures they need to follow if their rescue is needed or if there's an emergency. And the plan must address all situations where rescue may be required. And then the proper steps needed to safely return workers to the ground. This needs to be written out in detail and provided to the guys in the field. The rescue plan there's different methods, but typically includes some sort of self rescue. assisted rescue with others in the work area, whether that be other man lifts, cranes, or somebody that's working on the structure who can descend down to the man lift to help, or a technical rescue, which is often referred to as our last resort, which would be emergency services. Mostly because you need to plan for the account. I'm sorry, you need to account for the response time and availability of those services. If you're working in a 180-foot man lift and it gets stuck in the air, I don't know of many ladder trucks that can reach that high. So not having a plan or using an emergency services as your rescue plan may just leave you stuck anyways, even if you planned for it. So you need to make sure that you have the proper plans in place in order to rescue your guys in the event of an emergency. So a couple of things, like if the emergency is a system failure, all man lifts are required to have auxiliary power function for the controls. These secondary manual emergency descent systems are essentially buttons that are located both on the top and on the bottom controls. There's still a little lightning bolt insignia, but basically what this means is you can press that button and then press the control on the chassis that you want to control, up, down, boom in, whatever it may be. And without the actual engine running and the power, you use auxiliary power to bring the basket down should either the top or bottom controls fail. This is a commonly unknown feature. Most people aren't even aware that it's an option, but it could be critical in getting guys to the ground in the event of some sort of system failure. If those functions are not available, if even those have failed, controlled descent from the basket using a two-rope system is an option as well. But if you didn't plan for that as an option, how are you going to get your ropes up to your guys, right? Either you need to have those rescue ropes already in place with your IDs and rope grab systems ready to go in the basket, or a really good option is something like this, where you go get an arborist throw line with a beanbag and you keep it in a little kit inside your man lifts. That way, in the case of emergency, you drop the beanbag down to the ground, pull it up to yourself with your rescue ropes, anchor off to your designated anchor points, and zip on down to the ground without the use of any of the systems that may or may not have failed on the man lift itself. No matter what, when you're using any of these systems, you need to follow the manufacturer's directions, and the plan should be included in operator training and occupant instructions. Still a fun note there. So that's if you remained in the basket during an emergency. So what if the emergency is a fall from the actual platform? So we've been tossed out of the basket, and now we need rescue. Okay? First and foremost, the plan must limit the time a worker is exposed to suspension. We all know suspension trauma is a major concern, when you're working in a harness. So we need to have a plan to get those guys down to the ground or back into the basket as quickly as possible. So how do we do that? Well, a couple options come to mind. Lower the platform manually using the ground controls, or if the tower controls or the basket controls are still available, let's get that thing down to the ground, get his feet on the ground as quickly as possible, and then we can unhook him and save him that way. If for some reason that's not available, technical or controlled descent rescue from the basket utilizing a two-rope system, again, similar to having to do a bailout. And if there's not fall from the platform, maybe what you need to do, where you descend down from the basket, pick the guy up, and continue down to the ground with him in a man-to-man type of rescue. So whatever your rescue plan is, you really need to be taking into consideration all the different hazards that you could be facing and what's actually going to work for your specific job, and write that plan out. Some general considerations. Rescue should always be carried out by appropriately trained personnel, using the machine's ground controls and secondary lowering system when feasible. We don't want to jump into a two-rope system and expose more employees to a fall if we don't have to, right? So step one, try to get them to the ground using the controls. If that's not an option, then we can go into technical rescue. But no matter what you're doing, your guys should be trained on how to do that. If you can work with a manufacturer to rent out a machine and practice this at low levels using safe methods, that's a great option. That way, if it does happen in the field, you guys know how to do it. Rescue utilizing a secondary MEWP or platform/basket. If you're working in tandem with a crane, it may be an option to have a man basket ready to go on site, where you can transfer or even pick up a fallen worker from a basket or from his fall protection system in the event of a fall into that man basket and get them transferred out from there. Controlled descent from the basket using a two-rope system, maybe an option as mentioned before. And like I said, always follow the manufacturer's instructions. If the platform has become trapped or snagged, occupants should be removed prior to any efforts to free the platform. So if you get that platform jammed under a rooftop, you can't get it out. Let's get the guys out of the basket, rescue them from there, and then try to free that platform using the ground controls or whatever the best option is, so we don't accidentally cause injury to the guys in the basket while they're set trapped. Okay. All right. So entering and exiting at height. When it comes to having to leave the man basket to jump onto another structure, it is most manufacturers will allow you to do that, but you need to have a method of procedure written out. With that written plan or method of procedure needs to cover how you're going to prevent the people from falling when they're doing their transfer. Dropped object prevention is a major consideration. As I go with me, how are my tools going to travel? Are they tied off so they don't fall and strike somebody below me? How are we going to prevent sudden or unexpected movement of the platform that could cause a fall or dropped object? Stability or overloading of the machine due to change or additional loads, mostly a consideration if I'm going to be bringing people into the basket with me. How is that going to change my loads? Am I putting too many people in the basket and overloading the machine? Or am I going to cause a tip by rapidly removing weight? um, Dynamic loads from the fall protection equipment, from your fall protection equipment. Basically, what we're saying is if somebody were to take a fall while transferring from the basket to a structure or vice versa, and they are tied off to the basket during that transfer, how is that going to affect the man lift? Are we on unstable ground where it could topple the entire machine? These are the sort of things that you need to be aware of. Stranding of people. This is a major one that people don't consider when they use a man lift on a tower site that may not have, let's say, a monopole without the step pegs, right? Man lift is your only option to access. You can't just send one guy up in the machine, drop him off, and then leave a guy back down, take the man lift back down to the ground and leave it there, right? Because then what you're doing is you're leaving that person at height with no way to get back to the ground should the machine fail to make it back up. So it's something to be taken into consideration when you are writing your method of procedure for entering or exiting at height is making sure there's no possibility for you to strand somebody on a structure. The use of single or double leg lanyards. So if you're only using a single leg lanyard and you need to tie off to a structure to make that transfer, at some point, if you're only using a single leg lanyard, you're going to be free climbing. And that's something we absolutely do not want to do. So if you are doing a transfer of some sort and actually stepping off onto another structure that requires you to be in a fall protection, such as a tower, make sure we're using a double lanyard system so that we can effectively make that transfer. And then the distance between transfer surfaces. We always want to transfer from even surfaces. We don't want to be having to jump or climb in order to uh, get to where we need to go. The only other thing that's not listed here is at no point can you ever climb over the basket. We always want to set it up so that we're entering and exiting through the appropriate gates on the lift itself. Because as mentioned before, we're never allowed to climb over the handrail or step on those mid rails. Other considerations for traffic control. A lot of times when we're using man lifts in heavily populated areas, there is a risk that somebody could crash into the man lift and cause it to tip over or throw the occupants out. So when you're working with traffic control, you need to establish a work zone that isolates the man lift and the workers from traffic. Traffic cones are one way to do it as a warning system, but really what we want to be looking at is barricades that would prevent, even in the event of a vehicle losing control, something that can stop it from making contact with the man lift. Other ways you could do this are truck mounted attenuation devices or TMAs, but really you're basically going to be looking at barricades is kind of what we're going for. Warning signage and controls should also be established. If you're not sure how to establish a effective traffic control work zone, MEWP has guidelines for operating near public roads. That's a really good resource you can go look at, and they'll kind of outline how you need to set those zones up. And then ensure movement of the MEWP does not interfere with pedestrian or traffic without controls in place. So you don't want to be driving it through public spaces. And as always, spotters and flaggers may be required, but I highly recommend it at all times. They can solve a lot of your problems. In the tower industry, this is a big one. We see this a lot of misuse when it comes to man lifts, mostly pertains to loads. Working on stealth towers with stealth panels and things like that. I think we've all seen it if you've been around for a little while, and that's not how these things were intended to be used. So when it comes, you can use man lifts to move loads from place to place, but only within the manufacturer's guidelines. So first and foremost, you never want to exceed the manufacturer's rated load capacity. This would include the personnel, tools, materials, accessories. All of these things combined together make your total gross load that you make sure you're not going over the man lift capacity. So every man lift should have a label that gives you the manufacturer's recommendations on loads that it can carry. First, that's the weight is the first consideration. And then secondly, carrying materials larger than the platform itself is prohibited unless specifically allowed by the manufacturer. So the kind of good rule of thumb is if it fits within the confines of the basket without going over the top or spilling out of the edges, and definitely not hanging anything off of the side. And then as long as it does not overload the platform itself weight-wise, you're probably within spec. But again, always want to refer to the manufacturer's guidelines and requirements for that, because some of them may say no materials at all, right? You really need to pay attention to that. If you are going to load a man lift, you want to distribute those loads evenly across the platform. Avoid concentrated or point loads that could compromise the stability or floor integrity, and then always position materials close to the center of gravity to reduce the tipping risk. When it comes to dynamic forces, lifting, swinging, or shifting loads can affect the platform balance. Introducing of dynamic forces that exceed the rated capacity, such as taking a fall in a way that it's not designed to. And then always move loads slowly and smoothly so you don't over swing your basket and cause a tip over. ANSI does prohibit suspending or hoisting loads from beneath the platform unless the MEWP is specifically designed for it. So most of the ones we use in the field, you can't hang anything from outside or underneath it. They're not cranes. Tandem operations with a crane are the way to go. If you need to access a tower with a man lift, but you also need to bring a decent amount of heavy materials that won't fit inside your basket or will overload the basket, get a crane out there, call it out, working tandem with the crane, and that way you also have a secondary rescue plan if that crane comes with a man basket. So it's kind of a win-win situation all the way around. There are some manufacturer-approved attachments, such as the pipe rack that's you can see in the photo here, that may allow you to carry things that are slightly larger than the basket itself. You'll still never overload, but the manufacturer has approved this attachment for that specific job. So those are available to you. There's lots of cool accessories that you can put on a man lift or request from the manufacturer for all types of different scopes of work. But work with your manufacturer, your dealer, tell them what you're dealing with for your scope of work, and they can help you find a solution. Um, Last little slide here. Anytime, again, when we're taking things up, there's always going to be a dropped object hazard. Just as if we were working on the tower structure, when you're working out of the man basket, you have to prevent anything in the basket or anything attached to you from becoming a dropped object. Using things like tethers, buckets, tool attachments for like drills and things like that is always a good idea. You should always avoid placing tools or materials on either the guardrails or the platform floor unless it's tied off, because you have you run into the opportunity to kick it off and it becomes a dropped out object. Toe boards must be installed on the platform, and meshing or guardrail covers may be necessary. This is a good option if you want to wrap the entire platform. That way you don't really run the risk of accidentally kicking something off of the platform and hurting somebody below you. No matter if you are using tool tethers, buckets, meshing, whatever you want to call it, you should be establishing an exclusion zone or beneath and around the man lift, using barricades, cones, signage, what have you, to restrict access. So nobody's accidentally walking through, especially the public, who may not be aware that something's going on above them. And then you have something fall, strike that person, and you're in a whole world of trouble. So maintaining the communication with the ground crew, and then, like I said, prohibit those non-essential personnel in the area to make sure that they're never exposed to those dropped object hazards in the first place. Guys, I want to say thank you. I know that's a lot. It can't replace training. You guys should still seek out effective training, but I hope, if nothing else, this kind of gives you a crash course into, oh man, I should be looking at these things. This is maybe something my company is deficient in and we could be doing better. I am always available for questions if you have them. My contact is on the screen here. Send me an email, give me a phone call. If I can't answer the question, I have a whole Rolodex of people who are a heck of a lot smarter than I am. I'll point you in their direction and we'll find a solution. But thank you, everybody, for your time today.
Josh, I'm looking through the question block here, and it doesn't look like any questions were submitted. So great job on the presentation. On behalf of the TXOA, I'd like to thank you for volunteering your time to present on this subject. I'm sure it's going to bring a lot of value to TXOA members and really anyone who's going to watch this presentation. If any questions arise later on that we didn't have time to submit today, or if you guys think of any questions later on, feel free to go to the TXOA website. There's a contact tab on the top right of the website. You're able to submit any questions. Josh is a member of the safety committee on the TXOA, so those questions will be forwarded to us, and we'll be able to answer them there. Once again, thank you for your time, Josh. Jeremy, did you have anything to add?
I was just going to add, get your tickets. They're running out. You probably got about 2 weeks if you want to be at the event in Tulsa. That's all I'll add. You did a great job, Josh, and thanks for putting on the presentation. I think also, like Shane's saying, there's
Thanks
a lot
for
of
having me,
valuable
guys.
information there that I think people can benefit from.
Thanks, all.
Yeah.
Wrap it up.
All right, everybody.
Thanks, guys.